We'll be looking at how to take thickness of materials through coating, performing ultrasonic thickness measurements when you have coating on the material. Before the advancement of technology, when you have a coated material and you want to do thickness measurement, we normally remove the coat so that we can get a bare metal before taking thickness. But over the years, technology has advanced and we cannot take thickness through coated material. But a lot of times we find the inspectors and the technicians making mistakes when trying to take thickness, either due to the design of the equipment or the setting of the equipment and the other factors. But one fact still remains, there are some UT equipment that cannot accurately measure thickness of true coat material. So the first thing for the inspector to do is to be able to identify such material, such equipment. So let's look at the concept. Now we'll just look at the concept and get some idea of how it works. If I have a material, if it is bare material that is not coated, basically we want to get our thickness, we put our probe, and when there is reflection, there is a readout on the machine which gives you whatever the thickness of this material is. Pretty straightforward. Principle of ultrasound. We pass in high velocity sound through this material, it gets to the back row, is reflected back and comes back to the probe, and the probe processes it and gives us the thickness of the material. When we have a coated material, if this is a coated material, so coated material means it's painted or we have some other form of coating. But take note, this is not a heavy coating like insulation. When you get to that level, a different technology is used to measure the thickness of the material. So if this is a metallic material and this is a coating, if you put your probe, let's say this is 10 mm, let's say this is 10 mm, and this is say 1 mm. The idea is when you are taking thickness in this material, we don't need to add the thickness of the coating, because by the time we add the thickness of the coating, it becomes 11 mm. When in natural sense, we are looking for a thickness of 10 mm. If you are doing analysis such as calculation of corrosion rates and determining the remaining life of this material, this 1 mm difference can make a whole lot of differences between your calculations and you are going to get at the end of the day. So it is very, very good. There are some materials where the corrosion allowance is even 1 mm or something very, very low, and having such high reading can lead to misleading results. So what do we do? The first kind of equipment that you are going to use when measuring true coat, we have some machines that we call them true coat thickness gauge. By their design, true coat thickness gauge, they can just measure the thickness directly and subtract the thickness of the coating from the material and give you the final reading of the material without adding the coating. So we have units like that. Then there are some other units that are designed to what we call the echo to echo. In this case, you set the unit to recognize this concept of echo to echo. Immediately the machine knows that it's echo to echo, automatically it will give you the thickness of the material without adding the coating thickness. The first type, true coat, a typical example, you have your Cygnus 1 and the other brand of Cygnus machine. But the typical Cygnus 1, you don't need to even do anything. In other ranges and models of signals, you maybe signals 2 all the way to signal 6, you need to set it that you are doing true quote measurement. So you need to set it on the unit. In the case of echo to echo system, you have your 38DL, your 39DL series. Immediately you set it in the units echo to echo thickness measurement, automatically it will give you the thickness. Then the third method is using flaw detectors that have the ability to perform whether what we call gate to gate, echo to echo. Then we also have what we call flange to flange. Flank to flank rather. Flank to flank. Let's look at these concepts now. The first one, the true quote. How does this work? In the true quote method of thickness measurement, the probe takes the reading through what we call the multi-echo system. What happens is this: the probe, if I have a coating, let's say this is the coating, the probe sends in a signal. Of course, this will be reflected back, reflected back, reflected back. Oh. So what happens is when this probe sends in the ultrasound, it goes, the ultrasound goes through the coating, it considers the thickness of the coating, goes, and by the time this echo is reflected in multiple times, it takes the difference in the reading between multiple echoes. When it gets the same reading, that is what becomes equal to the thickness of the material. It is being built into the design of the unit so that it calculates multiple echo. When they are equal, it gives you the final result. There is a major drawback in this method. Especially you will find the units like this one. Because of the multiple echo, we require that the backward needs to be flat. So if I have a backward that is irregular like this, no matter what happens, when the multi-echo hits this backward, it's going to be scattered. In such a case, when you are using your signals machine, you will never get any reading, whether it is true quote or even without quoting. As long as there is a distortion in the backward, you are never going to find a reading. That is why sometimes when you are using a signals unit, you find out that the surface you are testing is clean, but you are not getting any result. It could be as a result of the backward. So one thing that this multi-echo method does is it relies on a smooth backward surface for you to get your final result. But if the surface is clean and everything is right with the unit, it will automatically give you the true quote thickness of the material through this multi-echo system. In the other case, with the echo to echo, automatically the machine will. So if I have multiple echoes as a result of the backward, so normally if I have a unit, even if it is coated and I have my probe, when this thing goes, it comes back. When it gets to this surface, it is reflected back. It is reflected back, thereby leading to multiple echo. So what the machine sees that it does not take the thickness based on the reading of this first echo. Rather, it compares the distance between these two echoes as a result of the reflection of these echoes that are coming in, and subtracts. Because normally, if I'm looking at, if this is 15 mm, if that's the thickness, the assumption is my first echo will be at 15 mm, my second echo will be at 30 mm. By the time you subtract it, even if the third one is there, it's going to be at 45. By the time you subtract it, you are going to be getting 15 mm without considering the thickness of the coating that is on the material. So this way, the machine automatically does echo to echo, as in the case of 38 and 39 DL. You have to set the machine in this echo to echo mode. If you do not set it, the machine will not do anything. It will rather give you the thickness, including the thickness of the coating. The third one is the flaw detector. Typical flaw detector that I'll use to demonstrate this will be my sonar test. Either I'm using my D10 or D20 or D70, or even the latest edition, which is the Wave. If you use any of these, it has a provision for gate-to-gate measurements, echo-to-echo measurement, and flank-to-flank measurement. If you look at the right menu, for the flaw detector, when you go to the measurement setup, it will give you an opportunity to do gate-to-gate, echo-to-echo, or flank-to-flank. So let me explain the concept. In the case of gate-to-gate, the machine recognizes you using two gates. So if I have measurement from the unit where I'm having multiple echo, the machine gives us an opportunity to turn on two gates, my gate 1 and my gate 2. Immediately you set the machine in the gate-to-gate mode, the machine automatically expects you to turn on your gate 1 and your gate 2. So what you manually do, you put your gates on the first echo, the gate 1, and put your second gate on the second echo. Immediately you do this, the machine no longer gives you just the reading of one gate. It gives you a reading of gate 2 minus gate 1. So like we said before, this is 15, this is 30, this is 45. It gives you the reading of a 30 minus 15, which is 15. If I decide to, on the other hand, put gate 1 here and put gate 2 here, it does the same thing. And in this case, it eliminates any form of putting, because if you are taking reading of only the first gate, the reading of only the first gate will probably give you the reading of the material plus the reading of putting. So if you don't want to make that mistake, you set gates to gate. So when you are doing thickness measurement using the gates to gate mode, you will continuously begin to adjust the position of your gate as your echo is moving around. It could be quite stressful for some personnel trying to juggle between two gates, but sometimes it's a very accurate way of getting your results. Because of this whole stress of jumping between gate and trying to adjust to two gates, the concept of echo to echo was introduced. Instead of using two gates, you just use one gate, and the gate crosses the two echo. So in the case of the echo to echo, the machine automatically differentiates the interval between the two echo, subtracting 15 from 30 and giving you the final result. The drawback of the echo to echo method is this: if peradventure there is even if it's a small echo that comes in between and is not really the backward echo, the machine does not recognize which one is frontal or backward. Machine will pick just the two close echoes and take the difference. So it can give very inaccurate readings if it is not properly adjusted. So you make sure that your echoes are the dBs are very high, giving you high amplitude, and you set your echo crossing them. The machine automatically will do the remaining part of the work. If you are not so sure, you can stick with your gate to gate and manipulate your two gates. In the case of the flank to flank, normally for every echo, from every echo, there is what we call the peak, which is the highest point. Then there is the two flank, the starting flank and the end flank. So if I say flank to flank, for the flank to flank, it also makes use of two gates, but this time, instead of getting the reading of the peak of the two echoes, in the case of echo to echo, is trying to get the flank measurements. We'll now illustrate practically the true coat thickness measurement. I have 4 units here. This is my typical D meter. I have my Cygnus 1, I have my 38 DL, and a Sonatest D10 unit. So for the D meter, I just brought it for the purpose of illustration. This D meter as it is, some of them are true code, some of them are not true code. So it is the duty of the inspector to ensure that they go through the manual of the machine or go through the setup to determine if the unit is actually true code or not. By application, this unit is true code. So in your setting, you can set it true code. When you set true code, it automatically gives you the thickness of the material without adding the thickness of the coating. For the signals on its own, automatically by default, this model of signals will give you the thickness of the material without the thickness of the coating. So this by design is true coat and makes use of the multi-echo system. The drawback of this is if the back is rough, the back wall of the material is rough. It's very, very difficult to get anything. The next one is your 39TL. This has a feature for the standard measurement and the echo to echo measurement. If you look at this button zoom, you will see an inscription here, E to E, which is the echo to echo. So if I turn on my second function and I touch this zoom button, it will give me the option to do standard, which is without the coating, auto echo to echo, or manual echo to echo. Standard, like I said, without the coating. Auto echo to echo, it is the machine that will automatically determine the differences in the echo distance and give you the result. A manual echo to echo, it is you that will manually look for the difference in the different echo and set it for the machine to take effect. Normally, if you are doing echo to echo, just do auto and save yourself the stress. The next one is my Sonatest D10. If you look at the menu under the measurement menu, under the measurement, when you come to your measurement type, when you look at the mode, you will see the option of depth, which is your normal depth for your coated and uncoated material. So if you pick your depth option, it's just only going to give you the depth of the material. Invariably, depth is thickness without considering the coating. The next, but if this material is coated, it will take both the thickness of the material and the thickness of the coating and give you the results together. But if you want to consider coating, you have the option of your E to E, which is your echo to echo. The trigonometry is for flaw detection. Then you have the gate to gate and you have the flank to flank. So this unit gives you this option. With the E to E, G to E, and F to F, you are able to get your thickness. If we come back to the D meter, just the setting and it will give you your reading. If I turn on my signals, and this is a 20 mm plate, plus or minus. If I put my thickness gauge here, you are seeing 8.8 mm. This is a wrong reading. In the back of this plate, we have some indications and corrosion lamination inside. So that's why the reading is not so accurate. Then secondly, if the coating is not properly bonded to the surface, it can also give you low reading. So, which is one of the disadvantages of using the signals to do true coat measurement. If the back wall, like I said, is rough, it's going to give you a rough reading. If the coating is not properly bonded, it's also going to give you reading. But if we apply couplant and we check the reading, we are going to be getting our 20 mm reading, irrespective of the coating. So this is pretty straightforward. If we check our 38TL, now I'm on that mode to set. If I pick standard, If I pick standard, which means in this case, it does not consider the coating. If you look at the reading we are getting very reading. If I now the is at some point we are trying to get the reading of the coating, which is about 2 mm. In this case, it's giving me the reading of just the coating. When I go to an area that the coating is good, I'm getting 22 mm as my reading. 21, 22. You see, in this case, this plate is 20 mm, but I'm getting my reading of both the coating and the plate. But if I come back, I do my second function. If I come back to my second function and pick the option and I take my auto echo to echo, so we are now in the echo to echo mode. If I take my reading, you can see now the same area I'm getting 19.9, which is approximately 20 mm. So the machine automatically recognizes that there is a coating and it has subtracted the thickness of the coating. Now, if I'm using my D10, this is a little bit more stressful in the sense that if I turn on, say, the gate to gate mode, my 2 gates are out. For me to get the reading, I can now go to either of my gates. I move, my gate 1 is already on the first reading. I go to my gate 2. I go to the level and I bring it down. You can as well increase your gain. So whatever reading is given to me here now, you can see it is a 19.7, 19.8, which is the correct reading of the 20 mm plate. So this is the echo to echo mode. If I go back to the measurement menu, and I pick, this is my gate to gate rather. If I go back to the menu and I pick echo to echo, I'm just going to have 1 gate. But what I need to do for this 1 gate, I need to extend the gate so that it crosses the two, it crosses the 2 echo. If you can see, it also giving me the same reading. But if I cross only 1 echo, you see it did not give me reading because it's waiting for an echo to echo reading. So I have to use this gate to cross the second echo before it will give me the echo to echo reading. The same applies to flank to flank. If I go to the measurement menu again and I pick a flank to flank, it's going to consider flank reading. This time is taking the first flank and the second flank of gate 1 and gate 2. You can see the reading now. So this is the D10 trying to give us the thickness of the material irrespective of the coating. I hope this explains the concept and we've learned 1 or 2 things. Thank you.